the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the recycling of elements in nature. This will be our second lesson on this topic. In our last lesson, we defined the term fixation and discussed the carbon cycle. We learned that the carbon cycle involves the ways carbon moves through organisms and the environment. We discussed the movement of carbon through photosynthesis, respiration, and combustion. In today's lesson, we are going to discuss the nitrogen cycle. We will show what it looks like and learn about how it works. This is going to be an interesting lesson. Students, if you are ready, let us begin. Nitrogen is a very important element in biological organisms. It is one of the constituent elements in both proteins and nucleic acids. Nitrogen is an important nutrient for life. I am sure you remember from previous lessons that about 78% of the Earth's atmosphere is comprised of nitrogen. However, most organisms cannot use it in its elemental form. This is because nitrogen's triple bond has large dissociation energy, which means that the bond is very strong, and nitrogen is quite inert. We learned about fixation in our last lesson. In order for nitrogen to be transformed into a usable form, it must go through fixation. Nitrogen fixation refers to the conversion of nitrogen gas into nitrogen compounds. This type of reaction can be initiated naturally. Lightning can break nitrogen molecules and enable their atoms to combine with the oxygen in air. This reaction forms nitrogen oxides, which are then washed into the soil by rain. Bacteria, such as those found in the outgrowths on the roots of legumes like beans, lentils, and peas, can convert atmospheric nitrogen gas into nitrates. The plants use the nitrate to produce plant proteins. Therefore, soluble nitrogen compounds in the soil can generally be absorbed by plants to make plant proteins. Animals eat these plants and turn the plant proteins into animal proteins. Then they excrete nitrogenous wastes, partially as urea or uric acid. These wastes are returned back into the soil. Other bacteria that live freely in the soil fix or change nitrogen gas into ammonium. This ammonium can be used by plants after it goes through a process called nitrification. This means that the ammonium is again changed by bacteria. This time, it is turned into nitrites and then into nitrates. The nitrites must be changed into nitrates because a buildup of nitrites in the soil can be toxic to plants. Bacteria are able to fix atmospheric nitrogen easily at room temperature. People, on the other hand, need expensive industrial machinery, high temperature, and high pressure to do the same. There are also industrial chemical processes that involve the fixation of atmospheric nitrogen. Haber's process for manufacturing